So here's a quick demonstration of my data structures final project. Now what we were tasked to do was create a database that's like SQL, stores data on disk, loads it from disk. Pretty simple. Uh, the way I did this was I created a D plus tree structure, or what I call D plus tree, which is really just a B plus tree on disk. And if you don't know what a B plus tree is, it's very similar to a B tree, except the internal nodes actually only hold a small portion of the actual data, and all the data is held on the leaf nodes. And like you'll see here, 31 is repeated in the leaf and 38 is repeated in the leaf. And that's because the leaf nodes are supposed to have everything, where the internal nodes are just used in order to travel down the right path in order to get to the right leaf. And the way I did this on disk is I pretty much treated it exactly like you would treat one in memory, except instead of having pointers, I had stream positions that point to the position in a binary file that a leaf is in. And that worked really well, but it's still not the best way to create a B plus tree on disk, because the actual internal nodes don't need to be stored to disk. They can just be created when you construct the object and stored in memory, because they only consist of 1% of the total data in the database, and you can save that on memory for almost any reasonable size database. So anyways, this is how I did my actual index tables, not how I saved the records. The records I just saved consecutively in a binary file. And here's all the classes that I created. The actual database class, which has just some basic functions: run, transact, which just executes a query, and then some private members: execute command, create table, load table, close table, select table, insert, rebuild, display, basic stuff. Then here's my individual record class, and with this record class you can actually save an individual record, or like a row in a table, to file, and the unique ID is actually the position in the binary file that this record's located at. And so you can mark it deleted, you can load it, you can save it. It makes it easy to manage individual records. And then here's my actual data table class, which is what a table is in my database. And what this will do is it'll load up the table file, which is a file of these records, and it'll scan the first couple bytes as an integer, and then that'll tell it how many columns there are, and then the next few bytes are the name of those columns. So it reads that integer, then reads in that many number of strings, or C strings, and then it starts reading records, because after the column names is all record data. And so it actually sets this this record start to the position right after the column names in the binary file, so you can immediately go back to the beginning of records really easily. And this table class actually uses this data buffer structure or object I created. And what that'll do is you pass in data buffer a certain size in bytes, like 1 megabyte, a gigabyte, any of those, and it'll load chunks of the record file, or chunks sized to that many bytes. And so here's actually the data buffer class. So like you can see, max memory usage, gigabyte, 1024, that's 1 meg by default. And then this has like read block, write chunk, which is just a random chunk of data. And then it saves the block locally in the private member variables. And you can access this block with some operators. I think I have. Yeah, here's the bracket operator. And so this makes it really easy to load huge chunks of a table and then unload them quickly. Or not quickly, but load and unload, and that way you can go through the table without having it loaded all at the same time. And then here's my actual D plus tree, or my B plus tree on disk. It's really easy to create an iterator for a D or a B plus tree, which is why I have one, because if we go back to that image, where is it? Did I close it? Yes, I did. Okay, back to this image. In a B plus tree, you can treat these bottom leaves as actually a linked list. So there's a little link, like one of these arrows, between this node and this node and this node and this node and blah blah blah. So if you have an iterator pointing at one, you can just plus plus along the whole bottom of the D plus tree, which is really convenient. Makes it easy to do things like find and things like that. And so here's my D plus tree. And then what I use this for in my data table is I actually have it type deft up here. D plus tree takes an index pair, which takes a column value and then a list of unique IDs. That's what an index pair is. And then add indices is a functor that I won't get into right now, but it basically defines the behavior of the B tree when you have repeating items. So like if you insert 5 and then insert 5 again, this functor will define what happens. And so these index trees are used to store unique IDs sorted by column. So it makes it really easy when you're selecting to like select first name and then everything's already sorted by first name, or select by last name, everything's already sorted by last name. And they get sorted when you insert them into the list. And yeah, so like I have a vector of index tree pointers, and each of these is like a column index tree. So now that we've been over the basics of my classes, let's do a little demo. Just full. That's wonderful. Gotta love Qt and its random bugs. That happens to me all the time. Gives me that error for no reason. My disks aren't full. Alright, we've got to compile. Now, because I don't actually, when I loaded a table, I don't actually load the data. The data always stays on disk. I just load like the little bits of information I need to construct the data table object and the D plus tree objects. And so I can actually load table info, which is a gigabyte big table, or it's 1 gig, and it loads that fast. And then we have, see, 1037 megabytes, which is 1 gig worth of data. Total records we got in this bad boy, 1 million. And here's the name of the table, first column, second column, last column, third column. And when you select a table, if you select star from info, it'll just print out the actual table info. Like, it doesn't do anything but print the starting chunk of info using the data buffer. So it prints the data buffer. And then at the bottom, it'll tell you what position the data buffer is in the file. So it's at position 0 or page 0. And then it tells you what records are loaded, records 1 through 2001. And then you have the option to go next, which will just take you to the next chunk. Like that. Very slow print, unfortunately. Takes you to the next chunk, and then you have go to, which will go to a page number, a specific page number here, and then reset, which will take you back to the very first page, and then exit. And so that's specifically for select with star, because when you're selecting star, you're selecting the whole table. You don't need to do anything, you don't need to filter anything, you just print the whole table. Now when I do something like select first name from info, that'll create a whole nother temporary table, and it doesn't actually construct the index trees for that table because you're just printing it, you're not selecting from it, so the temp table doesn't need those. And it'll take a really long time to create